Testing, testing. yes, we'll be taking a few minutes in the middle of the lecture at around 1 o'clock to have a nap, 10-minute nap. Then we will resume with the lecture at 1:10, and that will be that. In all seriousness, this topic is not going to take us the rest of the class. Well, so here we are again. The few, the proud, the 9 we have currently joining us for today. So, I have a few notes before we get on with the show for today. Primarily, I'd like to talk about what's happening with respect to the test next week. Let me just grab that again. There we go. So, with respect to the test next week, it was my observation that normally what happens when we have a test is that we have the test in class. And seeing as we do not have, it's an all-day test, so it's not in class, it still seems somewhat cruel to expect you guys to sit through a lecture on the day when you should also be writing a test. So we will not be having a test. Sorry, scratch that. We will be having the test. We will not be having the lecture next Tuesday. The test is still going on. Don't quote me on that. Yes. So there was also the T3 tutorial section, which also was going to occur Tuesday. That's going to be rescheduled as soon as the person who's running that gets back to me about when they're rescheduling it for. So the other thing that bears mentioning is if you are a person who has a SAS accommodation, normally it's very common with SAS accommodations that people get extra time allowances on tests. So with respect to this upcoming test, for the purposes of calculating these time extensions, we are going to consider the test to be a 24-hour test, which it actually is. So if you have, for example, 30 extra minutes for every hour, then you will receive an extra 12 hours for this test, as that is the proportional ratio. So, that's all well and good. Would there be a CO2 stream today? I just want to keep the lectures consistent. Yes, there will be a CO2 stream today. The CO2 stream will be occurring immediately after this one at 1:30. Indeed. So, yeah, I'm not sure how much cross-pollination is occurring between the different streams, but hopefully I've been keeping the naming reasonably consistent on them. This is C01. Good. Excellent. So, with all of that being true, let us get a little bit into our lecture topic for today, we will continue our topic of visualization. Now, this is essentially the creation of graphs. Graphs are fun, graphs are nice, they do mathy things. We had talked about the increasing the curviness of the curve by introducing additional data points. We had introduced the f-range function, which is floating point range, essentially, which was defined on this slide. And we had stopped at scatterplot. So, I don't think it's necessary to go back over scatterplot. So, what we'll do, that looks terrible, jeez. Herp, there we go. So let's continue on from that point. Boop. So, if we want to graph stuff, we often want to graph stuff that exists inside of a spreadsheet type file. So, it is convenient to know how to graph things that exist inside of a CSV file. Just a quick review on CSV files. It's a plain text spreadsheet format. CSV stands for comma separated value. And we're going to use the approaches that we used in the previous lectures with respect to reading from CSVs in order to extract data that we can then plot on a plot. So, there are a couple of libraries that you can use to make this more expedient, specifically numpy.loadtext and pandas, but we're going to do it in the same manner as we have been doing it so far. So, if we wish to import data from a CSV file, the first thing that we need to do is import that CSV. We then have to create the file handle and the range of applicability for the file handle. So with open, the file name in this case is sample.csv, comma, r as file handle. Incidentally, I have taken this sample CSV file right here and I have written it to the directory that this Jupyter notebook is operating in, so it will actually be able to find this file. Rows is csv.reader operating over the file handle. X is empty, Y is empty, and for row in rows, X dot append row at the first index, and Y dot append row at the second index. So, of course, if you remember how the CSV reader function works, what it does is it takes the contents of the CSV file and writes it to this rows object. That rows object is iterable, which means we can use it in a for loop. And when we use it in a for loop, what we get back out again is a series of lists, which are all of the data in each of the individual lines organized into a list. So obviously, if we take the first index, that's going to be the first column, and if we take the second index, that's going to be the second column. And of course, everything is zero indexed. So after that, we just have to create our plot. X, Y, and pyplot dot show. And yes, we need to import. We need to actually import pyplot first. That would be good. Thank you. I was about to say something sarcastic to the computer. And there we go. So, here's a question. What is wrong with this graph? Please feel free to answer in the chat. Nobody? The axes are wrong. The axes are drunk. Yes, indeed. So, yeah, if you notice, while we have a nice 1, 2, 3, 4 along the x-axis, we have 4, 5, 6, 2 here. That is strange. Yes. So here's what's going on. When you import data from a CSV file, that data is automatically cast as a string. So, right now, PyPlot doesn't understand that it's dealing with numbers. It is, well, yes, I mean, obviously, right? Yes. So it doesn't understand that it's dealing with numbers right now. It thinks that it's dealing with strings. So it's dealing with these numbers as if they were strings. So in order to interpret these, we have to cast the values as integers. And there you can see we have a correct interpretation of these numbers as numbers. Where is the Q in your numeric system? Well, obviously it's right next to P. And on the other side of R, oh yes. Yes. Well, you know, numbers are an arbitrary construct anyway. The only reason that anybody uses them in the manner in which they're used is because it's conventional to do so. That is the power of convention. So, anyway, always remember when you're importing from a CSV file, you have to cast the data. Also, keep in mind, for those of you who think that the slides are the unadulterated truth, notice that the integer casting is absent from these slides, so that's actually a mistake. This code does not produce this graph. So, this is all good. So let's talk about an example, a further example, that uses CSV dict reader because we have header rows now. Very, very similar. We want to import the CSV library, although we technically don't need to do that because we did it in the previous cell, with open sample2.csv, comma, in read mode, as file handle, rows is equal to csv.dict reader, file handle, x is an empty list, y is also an empty list, for row in rows, x.append the integer interpretation of rows at what? What do we have now? Now remember, because, oh, those are decimals. Oh, actually, we have a question. Why does it plot? Oh, yes. Yeah, sorry about that. So the quality on these videos is limited by the fact, I think I may have mentioned this before, but my busted-ass old laptop is too old to receive video card updates. Like the GPU is no longer new enough for them to be writing driver updates for it, and I don't really want to deal with trying to use like non-supported drivers. So basically everything here, the encoding is having to go through my CPU rather than the GPU. So there is going to be a hit on quality as a result of that. And if you guys want better quality video streams, y'all can chip in and buy me a better laptop. Lols. So anyway, because we're now dealing with a dictionary rather than just a simple list, we are, of course, addressing things by their keys rather than by their positions. Int. Well, actually, so I was about to write int, but if you... Oop, pardon me. If you take a look at the actual data here, we're calling for close in this example. Whoa, what? That is weird. Oh, okay. My computer has ghosts. Must have been talking badly about it. If you take a look at this data, it's actually in float format. You're such a suck up, Moonstar. Teacher's pet, teacher's pet. So you want to interpret that as a float. pyplot.scatter x and y, pyplot.show. Oop, what have I done? I have misspelt rows. That is, what else have I done? Not subscriptable. Oh, yes. There we go. Question. Is Corona Bunker Corona safe? Well, I mean, no. Nope. The problem that we have in society that it's, you know, almost completely impossible to completely isolate yourself, and you never know. A person can always open up my storm door and cough on my door handle in the night when I'm unaware of it. So there you go. It's reasonably. We actually have disinfection procedures whenever we come into the house. We spray ourselves down with, or just the hands really, spray our hands with rubbing alcohol so that we kill anything that might be on it. And we wear gloves while we're out in public so that it's not really so we don't have to touch anything. It's so that we remember not to touch our faces, because it's a lot easier to do that if you have something on your hands. But anyway, so as you can see, this code works. We've got a correct interpretation of the data. So, with respect to the customization of these plots, up to this point, we've been doing very basic plotting that has nothing fancy. Like, we don't even have axis labels here. And if you're a scientist at all, you know that the axis label is part of the most important part of the graph. So, there are a number of methods that you can invoke that add to a plot all of these things that you might be interested in. So, for example, pyplot.title will add a title string to your plot. And you will notice that this is the most original type of title for a plot possible, which is just to state what the x and y axes are. We also have xLabel, which labels the x-axis. And we have pyplot.ylabel, which labels the y-axis. And we can also, so we can also modify how much of the screen is shown. We can modify the ranges on both axes. pyplot.axis of evil, just kidding, 170 to 100. And pyplot.legend, we can add a legend. So the way that legend works is that you give it a list of strings, and it'll apply those strings to the data series in the order that you give them. So the first data series that you enter will be given the first label, etc., etc. So we'll call it this DJI for no particular reason. And of course, we can turn on grid lines. Question A9, question 2 also. So, question. Is it possible to do that? Okay. All right, I'll take a look at it. Question. Question A9. 2. Okay, I've written myself a note about it. Good. So if we run all of this, you can see we have all of the things that we were enforcing. All of the things have been, the modifications have been made. And this slide just shows exactly what I just did. So let's review some different types of graphs. If you wish to make a histogram, rather than using scatter or plot, you would use hist. That creates a histogram. If you want to create a bar chart, then you use bar. If you want to create a horizontal bar chart, you use bar H. Does pretty much exactly the same thing. Question. Is it possible to brute force your way to a solution, but a better it is possible to brute force your way to a solution, but a better explanation would be nice. As I said, I will look into it. Pie charts, everybody's favorite type of chart. Well, you know, business majors' favorite type of chart. There you go. Use pie. So the interesting thing about a pie chart is that you have data in one list and you have the categories corresponding to those data in another list, and you graph that. You add that to the pie chart with labels. The labels parameter being assigned to categories, and that will allow you to actually see what these are for. Without that, you just don't get any labels. So the labels are reasonably important. So if you wish to plot multiple things on the same chart, and actually let's go back up to our sine wave chart. Let's create a second set of y values. And we will modify the function slightly. So 1 divided by x. And let's make this from 1 to 5. Then, so I recommend a different way of going about this than the one that appears in the slides. Rather than, well, that's interesting. pyplot.pyplot? No. pyplot.plot x values, y values 2. So, in a previous live stream, I was trying to get this notation to work, and I couldn't. And I found that this is effectively the same thing. So, there you go. And just for fun, let's increase the frequency. Just to really get it to be a nice curve. There you go. Hey? Yeah. So, if you want to create multiple plots, that's how you would go about it. And just to demonstrate the whole legend thing, there you go. See how it corresponds to A and B. There you go. So, in order to plot date-time data, and we're going to be getting to date representations actually very shortly. In order to plot this data correctly, you have to use xticks, which is a different type of it again. So, again, for date-time data, you'll want to be using xticks as your plotting function. If you wish to save the plot to a file, then there is pyplot.savefig, and then you enter a file name. So, for example, if we go back up here to this lovely graph that we just produced, the thing that you have to understand about pyplot is that when you call pyplot.show, it actually wipes out all of the data that it had been storing inside of pyplot. It shows it and then deletes it, essentially. So if you try to save the figure after having shown it, it's not going to show anything. pyplot.savefig my pie chart, or not pie chart, my chart.png. There you go. Still shows it, so it still plots it. And then if you take a look, my chart.png, ta-da! There you go. And that's an actual image file. So there are many different other types of plots that you can use. This is just a small number of them, as you can see on screen here. So you can do 3D plots, subplots, you can add text and arrows, you can do error bars, you can have customization of all types and shapes and sizes. So it's very versatile software. There you go. So that's visualization done as a topic. So, yes. Just let me go here. So, I know I made a joke about us taking a nap at 1 o'clock, but as it turns out, I actually do require a 5-minute break right now. So we'll be back in 5, eh? Okay. So, sorry about that, folks. Wow. Let me just... My stream is stuck. Yes. Probably. Okay. Looks like we're back. Excellent. Sorry about that, folks. Excellent. Good, good, good. So, I apologize for that. That was not a good situation. It is what that break in the lecture there is probably preferable to you guys watching me poop myself on stream, but you know, maybe that would have had more entertainment value. Probably it would have. So, I guess the rule of thumb is, if you have tahini in the fridge that's been there for more than 3 months, you should probably throw it out. Rather than making it into hummus. Hello again. Hello, everybody. So, let us talk about another topic. This is an extremely short topic. We will be talking about how to get dates. No, we will be talking about how to encode dates. That's a different thing. So, dates. In the world, there are lots of different ways to encode date systems. So, of course, you have such calendars as the Gregorian, the Bengali, the Chinese, Ethiopian, Hebrew, Hindu, Iranian, Islamic, or even the Julian calendar, or the Aztec calendar, which ran out a few years ago. Calendar systems are actually reasonably complex. You have lots of things to consider, like daylight savings time, whether that's applicable in your region, leap years, leap seconds, time zones, and of course, there is the fact that pretty much every different part of the world has some preferred way of encoding their date formats. So, as you can see, most of the world goes day, month, year, smallest to largest. In the States, they have month, day, year. So, January 2nd, 1922, which is, of course, closer to your sort of standard English way of saying a date. A couple of regions have dual date systems, and the only country in the world that maintains 3 date formats simultaneously is us. Canada. Huzzah. So, When you're working with dates and times in Python, what you want to do is you want to use the date-time module to access it in a object-oriented fashion. So date-time is the module, and you have a number of you have classes within that module that do various things. So if you want to represent a date, it's datetime.date. If you want to represent a time, it's datetime.time. Dates are in year, month, day. Times are in hours, minutes, seconds, microseconds, time zone. Datetime.datetime is a class representing both date and time timeDelta is a class representing a difference between two times. If you wish to create a datetime object, it's very simple. From datetime, import datetime, print datetime.now. There you go. And that is the precise time at which this is executed. You can see it is the year 2020, the month is the 3rd month, 24th day, 13th hour, 14th minute, 8th second, and then we have whatever millisecond fraction we have. There you go. So, okay. When you are using date, actually, this is a fun one. Okay, let's do the rest of this example because it's fun. So, we will save what time it is now. The midterm is at date time, construct a date time object. Nope, we are 2020, 3rd month, 31st day, and it is, the hour will be 9 a.m., 0th minute, 0th second. Time left is equal to midterm minus right now. And let's print the time left until the midterm. So, until the midterm, we have 6 days, 19 hours, 44 minutes, and 18 seconds. So there you go. Some easy time-based arithmetic for you. Notice that the minus operator has been overloaded to be used with the date-time object. So there is, of course, the issue of string conversion as well. There are many, many ways to print a date-time object. You know, as we discussed earlier, there are many ways that people represent dates and times. So there would obviously be a number of ways that you would represent a date-time object in this sense. So if we wanted to print one of these, you would use the strftime, strf string format time method to format the date time object. So if you don't like how the default is formatted, you could say print midterm.strftime in string using our percentage signs to indicate string formatting. If you want year, month, day, space, hours, minutes, seconds. You could also do the time is. There you go. And if you want to change the order of things, like for example, you want to do it in the American style, although I can't imagine why you would want to, there you go. Simple, easy, wonderful. Also, the capital A gives you the name of the day, and it is a Tuesday, and it is a Tuesday. Probably put a new line character in there, and remove the space, and capitalize it. There we go. So there you go. You can also create a datetime object from a string using the strptime method. This is a process known as parsing. However, you need to, once again, be specific about the format of the thing being parsed. So, if we wanted to create, again, a sometime object datetime.strptime, first you enter in the string that you wish to parse. So let's imagine it is March the 15th, 1972. And then you would have another string which has all of the formatting options. So B is month name by name rather than by number. Then we have a space. Then we have the day format. And then a comma, a space, and the year, which is capital Y. And then, if we wish to print sometime, you can see that it has put it back into standardized notation. Ha! Yes, we have run out of time. Lols. So, thank you very much for attending the stream today. For those of you who may have any lingering questions, I will be jumping onto the other stream. Please feel free to ask your questions there. And yeah, until next time, folks, stay frosty.